Hello, this is the video explanation for homework 6, question number 2. In this question, we are given that fxy is equal to a value b, which is a constant, and the range for x and y are not like normally we have here, x equal to smaller than equal to y smaller than equal to something. Instead, we have a function for x, both x and y, saying that x squared plus y squared is smaller than 1. And 0 otherwise. In this case, this part is quite familiar from the x squared plus y squared smaller than or equal to 1. It's the same equation for a circle in the xy plane, and it's indicating that the circle has at most the size of 1. And so we have that as an important part of this question. And for part A, we are to find out the B, so that this function would be a valid joint PDF. And in order to find that out, let's see what we have here. Yeah. For part A, we have this indicates the area is of size pi, and in fact, if we go into the clue for homework 6, we have a graph there. Oopsie, it's not working. Okay, we have a graph here. Yeah, it's the area of the shaded area. It is yeah, size of this shaded area. And so in order to find out the what B is, what we really need to know is that the area of this is pi, and for this area times a specific height, we have the volume of this cylindrical object. The volume of that should be equal to 1. So what B should be is B times pi is equal to 1. This is the base area of xy on that plane. This should be the height, and the height should be 1 over pi. And that's it for part A. And for part B, we are to find out these expected values. And usually we just, actually in this case, we also just use the integration form. And for in order to find EX, we put the X here and find integration over X dx dy, the double integration. But it's not that we have X and Y both larger than 1 or equal smaller than 1, larger than -1. We have a circle indicating that shape. And from the hint, we know that we can represent Y in terms of X, and we have X from -1 to +1. If we have Y to -1 to +1, it's a square. It's not the case in our situation. We have a circle. So instead we fix X or fix Y, either way, and represent the other one. In this case, we fix X, represent Y in terms of X is this value and this value. So when doing the integration, it's integrate from negative square root of 1 minus x squared from this to square root 1 minus x squared from here to here. And we do the integration. We take the 1 over pi out because it doesn't have to do anything with x and y. And what we are left is just a 1, and do the integration, we have 0. And it's easy to know that for EY is the same thing. It's just we swap out this part and represent x in terms of y, and do the integration of x first in here. And we also know that this should be also equal to 0, just like this one. So EX and EY are known. And for ex given y, for ex given large y and ex given smaller y, we know that ex is 0. So these two should be also equal to 0, right? And for the y case, it's the same thing. This is 0, and these two are also 0. And in order to find the exy, we are doing the integration from of the range x and y, and putting an x and y in here. Do that integration of x dx over dx and the dy. In this case, we can represent the x in terms of y, or represent y in terms of x. Is either way is the same. And do that. In this case, I chose to represent y in terms of x and do the dy first in here. And after that, I get that this part is equal to 0, and so the entire integration should be equal to 0. And exy, so in the end, is equal to 0, and that's for part 2 or part B. Yeah. For part C, we are to prove or disprove that x and y are uncorrelated. Well, we know from part B that ex and ey are both equal to 0. We also know that exy is equal to 0. So this equation apparently holds 0 times 0 is equal to 0, right? So it is easy to know that they are uncorrelated. And I believe that's everything. Yes, that's everything for this question.